Hello, how are you? Welcome to this video where we will talk about, or I will show you the latest features released in Blazor in .NET 9 during the last .NET Conf. My name is Hector Perez, I am a Microsoft MVP, so let's see what these new features are. The first thing you need to know is that ASP.NET Core is a .NET platform that can help you develop all kinds of web applications. You can create graphical interface applications, APIs, data-related matters, and security servers. It has tools to create these applications. So it's a very complete environment for creating full-stack solutions. Many bugs have been fixed, and mainly optimizations have been made for the framework to work much better and faster. So the team focused on these improvements over the past year. Here are some data points about why this version of ASP.NET Core is the fastest version today. You can see some data here showing, for example, that specifically for Blazor, the application startup time is 25% faster. We have other features that you can research more about on different Microsoft websites. Specifically, regarding Blazor, we have some improvements that you can see on the screen. The first thing is that you can now detect the rendering mode of a component at runtime. What does this mean? Well, to demonstrate, I will open a new instance of Visual Studio. I will create a new project by selecting a Blazor Web app template, as you can see on the screen. This is the template you can see here. We will indicate that we want to create a project of this type. Let's name it, for example, Blazor Demo 1. We will leave the default path, click Next. We will select the latest version of the framework, which is .NET 9. We will leave this information as it is. What does this mean? Well, basically, if you have a component, the first time you access the page where the component is located, to have the fastest connection, Blazor Server Mode will be used to establish a sign-alert connection and visualize the component as quickly as possible. Behind the scenes, while you're browsing the website, a copy of the component will be downloaded, and it will no longer function in Blazor Server Mode. Instead, it will operate in Blazor WebAssembly mode. This way, when you run the application again, refresh the page, or do something similar, the loading will be much faster because you will be using the component locally instead of connecting to the server. So it takes advantage of the best of both worlds. I will leave the information as it is. I indicate that I want to create a project and wait for it to be created. I have changed the font size to make it more visible. Now, having this project, we will show a feature that allows us to know which rendering mode we are in. We will go to the project, specifically to the one with .client at the end. Let's open this folder of pages and open the component called counter, which is the component we know from before if you have worked with Blazor previously. I will modify this page. I will paste a code snippet that I have here, which is not very complicated. It's basically the same information, but I've added a few things. First, you can see that I've added an h2 tag where we are showing the rendering mode of this specific page. We do this through a property called renderer_info. We have many properties we could use. Well, just two, is interactive and name. So with name, we can know what rendering mode we are using. Also, another thing done as part of this page is adding an if statement to check if the rendering mode is interactive or not. What does pre-rendered mean? Well, the first time you connect to a website, the initial load to make things faster and to visualize information quicker will use static content of the components. This means it will not have any interactivity. This gives the user the impression that the load was very fast. Once the information or the whole component is loaded, the mode switches to an interactive mode. You can, for example, click on a button or perform some actions on a component because it will be in interactive mode. We can determine this through renderer info.isInteractive. This shows the pair of properties I mentioned earlier, both the name and whether we are in interactive mode or not. So let's start the application to see how it looks. Okay, ready. I'm going to the counter component, but I want you to see what happens in the central part of the application when I click on counter. Okay, you can see that the rendering mode is server mode and counter is running in interactive mode. I will click again. Well, here I can click on click me. We don't have interaction because we are in interactive mode. I will refresh this page and I want you to see what happens to the text on the screen. The first change is that the rendering mode was static, as I mentioned earlier, when we have a pre-rendering mode. What happens is that a static version of the web page is shown, and you can also see in this text where it says counter, it is in pre-rendering mode. So this refers to the first feature, or the first improvement, which states that we can detect the rendering mode at runtime. This is quite useful for creating some sort of loader, for example, while the page is loading, or to show certain information to the user when we are in one mode or another, etc. The second feature we can see is that we have improved reconnection logic. What does this mean? Well, to demonstrate this, I'm going to create a new project in Visual Studio. Once again, I will select the Blazor Web App template, leave the defaults, or well, I will change the name. We will call it Blazor NET 8. I will click Continue. This is because I will change the framework version to .NET 8. I indicate that I don't want any type of authentication, that is, I leave all the information as it is. It is the same configuration we used for the new project, only we changed the framework version. I click on Create. We will wait for the project to be created, which doesn't take long. Here we have it. I'll compile the solution to ensure no problems exist. We have a successful compilation. Next, I'll open the terminal for this project, which doesn't have the .client ending. Right-click, and here we have the option to open it in the terminal. Here it is. I'll start running this application from the console. I type .NET run. This begins the process of ensuring everything is running smoothly so we can open the application. In fact, it is already executing. We can open a new incognito window. Let's use HTTPS. We will enter the IP address, which is localhost with port 5145. Here we have the application with Blazor.NET 8. It has the same information as a normal application. I'll stop the application by pressing Ctrl+E. This stops it. Notice this message appears, trying to reconnect to the server. Here we see the number of attempts being made. I'll wait until it reaches attempt number 8. Or actually, before that, I'll reconnect. I type the command .NET run again. Okay, the application is now running. But notice that as soon as I launched the application, there seems to be a problem here specifically on the page. It says that this application cannot reconnect to the server and that we need to reload the page to regain functionality. Now we have the application running again in this web browser. However, this is not optimal for the user. In this new version of Blazor, I will again run the Blazor Server Demo 1 project, open the terminal, and enter .NET Run to start the application. I open the incognito window. Here we have the application running. I enter port 5221. Okay, we have the application here. Everything works well. Again, I will stop the application execution. Notice that it says that the application is basically being shut down. We have to wait a bit. Done. Once we have closed the application, we get this new window indicating that it's trying to reconnect to the server. We have a nicer graphical interface. This dialog looks much better and shows us what is happening behind the scenes. So again, I entered .NET Run to start the application. Notice that in this version of .NET 9, what happened is that once a connection with the application is detected, the connection is automatically reestablished. We reconnect to the application and can continue working without needing to refresh the page. So we have a new experience in this sense that looks much better and also feels much better. The third feature indicates that we can use static SSR in a global interactive application. We have this attribute exclude from interactive routing, which we can use so that if we create a globally interactive application, we can exclude some components from this form of rendering. So to demonstrate this point, I will do something different. I will once again create a new Visual Studio project, selecting Blazor Web App. I will name it Blazor Sec, for example, Net 8, to indicate that it is the version 8 of the framework. Once I change the name, I click Next. Here, I will select the framework. I will keep the .NET 8 version selected, and I will specify that I want an individual account's authentication type. I will select this option, leave everything else as is, and click Create. While the project is being created, I will once again open Visual Studio. I will create a new project with the same template. I will name the project Blazor Sec2, for example. I click Next, but for this project, I will select the .NET 9 version, meaning I will have the same project for version 8 and version 9. Once again, we select the authentication type as individual accounts. I click Create. This starts the project creation process. I will leave it here for now. The next step is to show you how this feature works, which, remember, allows us to use this attribute as part of the application. Well, when authentication is used in a Blazor project of this type, remember that I selected an automatic type project that works with both server and WebAssembly. This project integrates different components related to a user account. Let me ask you, if you wanted to authenticate a user, how would you do it? From the server or the client? Surely, the answer is from the server, where user authentication should be handled. Basically, they could manipulate the code because when you work with a WebAssembly application, you essentially have access to all the application's content. So, what should be done is that some components, or indeed all components related to user accounts, continue to be executed from the server. How is this achieved? In the .NET 8 version, if we go to the file called app.razor, you can see at the bottom, in the code section, these lines of code are used. And it is indicated or questioned if this final path starts with this, basically with this part of the URL, to validate whether we are working with an account component in that URL path or not. This is very useful, extremely useful, because it frees you from allowing user access to those authentication components, preventing the user from creating fake accounts or performing any malicious actions. This is how it is handled in .NET 8. Now, in the .NET 9 version, which is the project I created here, what is basically done, we can go back to components and to app.razor. You can see that here we have a different configuration. It is not the same code we had before, but the intention, one could say, is the same. Here basically what is done in this case in HTTP context is the use of a method called acceptInteractiveRouter. The definition tells us that this method determines if the current endpoint is a Razor component that can be reached through interactive routing. You might wonder, where is that attribute defined? Well, if we go back to the solution and open the account folder, you can see that under Pages, in the import.razor file, we have at the top the attribute with the exclude from interactive routing attribute. This is the attribute that is applied to all components that are part of a user account, following the same principle. We are blocking, so to speak, these components from being downloaded to the client's browser. Let's move on to the next point, which talks about simplified authentication state serialization in Blazor. So if we go to this project and open the program.cs file as part of the project, you will see that in one of the dependency registrations for this project, since we are using authentication, it is registered with scoped authentication state provider, and it is also used to resolve persisting revalidating authentication state provider. Let's go to this class. What's interesting here is that this class is not part of the framework, but rather a class created as part of your project. When you authenticate in this version of .NET 8, what happens is this method executes. As part of the method execution, it essentially retrieves the user data, the different claims defined for the user, and in case the validation is correct, it retrieves the user data, the user ID, and the email. Finally, it uses this persist as JSON method, which basically persists the information in JSON format with this user configuration containing the user's data. So, with this information persisted as JSON, if we go to the project that ends in .client and open the program.cs file, you can see that an authentication state provider dependency resolves to persistent authentication state provider. Let's open this class, and you can see that on the client side, remember that on the server the information was stored or persisted as JSON. In the case of the client, what happens is that in this constructor, persistent component state is passed as a parameter, which essentially the class that allows us to retrieve the authenticated user's state. And basically, here you can see that the claims are defined, and here we are trying to read the information from user info or the state, which is passed as part of this method. Then the claims are defined for the information we have obtained from this interaction between the server and the client. Let's go to the .NET 9 project to see how this works in the new framework. Okay, here we have our project. I will open program.cs on the server side once again. What I will do this time is show you that a different class is being used here. Identity Revalidating Authentication State Provider is being used. I will go to this class. You can see that this class implements the method we had previously, which allowed us to persist the JSON document, or rather the JSON object. This inheritance seen here we don't have in .NET 8. So this will allow us to save information or the authentication state more easily. If we go to the client side, let's open program.cs and note that in this case, we are no longer registering the instance in the dependency container as it was done in .NET 8. here this method called addAuthentication of serialization is used. So it's with this method that the deserialization from the server will be carried out to obtain the user information and ensure that the user is logged in correctly or authenticated correctly. So this point refers to simplified authentication in Blazor. The next point we will address or see is component constructor injection. This basically refers to having constructor injection available in components. Let's see this practically. For that, I will go back to Visual Studio. I will open the first project we created, which is the version. Or rather, I will open the second version. Here it is, the Blazor NET 8 project, the Blazor project with .NET 8. I will proceed to open the project in the client folder. As part of the project, I will create a new folder called Services. Next, I will add a new class, or rather an interface called iCoinService. Next, I will implement this class by creating a new class as part of services called CoinService. Again, I will paste a class here that basically implements the interface iCoinService through the return of a static JSON string. This is what the service will basically do. It will return a JSON string. So I indicate builder.services.addSingleton, CoinService, and CoinService. So I indicate builder.services.addSingleton, iCoinService, and CoinService, which is the class to be resolved. Once we have made this registration, we will go to where the counter component is in the .client project. As part of pages, I'm going to create the class where I'll add some code. So to demonstrate pages, I'm going to add a new class called counter. Basically, what I'm doing is creating the code behind of the component in an external class. This component expects an instance of CoinService in its constructor, which must be resolved by the dependency container. Next, in the onInitialized async method, I want to retrieve the CoinService information through the getCoinData method. With these changes made, let's start running the application. Remember, we're using Blazor's .NET 8 version. Okay, here we have it. It seems that in principle everything will work correctly without any problems. Let's see what happens if we go to counter. Okay, you can see we have an error here. Why is this error happening? Well, let's go to the application output, and you can see it indicates that it cannot dynamically create an instance of this type because we don't have a parameterless constructor defined. Let's see if this is the cause of the error. Let's create a new parameterless constructor. We'll run the application once again. Okay, here we have it. Let's go to counter, and now we already have an exception, indicating as part of Visual Studio that it cannot basically get an instance of this class called CoinServer. In fact, if we hover over CoinServer, you can see we have a null reference here. We are going to do these same steps, but in the .NET 9 version. I'm going to open a project. Okay, here I have it. I'm going to the .NET 8 project because I want to copy the services folder. Going back to the .NET 9 project. Okay, we have the folder here now. All I need to do here is adjust the namespace so that it matches the structure and we don't have any issues. Okay, with this, I have now added the service. I will add this line to register the instance of CoinService so that we can retrieve a new instance. Finally, remember that what I did was create a new class called counter in the pages folder. We need to specify that it's partial, and once again, I will copy and paste this code, place a breakpoint, and let's see how it behaves in .NET 9. Let's go to counter, and you can see that this time we don't have any problems. We do have the JSON information returned correctly and satisfactorily. So in .NET 9, you can inject references or have those constructors receive some type of reference with no issues. Lastly, we have a template added called Blazor Hybrid Web. What does this mean? Well, basically, let's go back to Visual Studio. I will indicate that I want a new project. You can see that if we select Blazor as part of the templates, we have the classic Blazor web app. In previous versions of .NET, specifically the .NET 8 version, we had this template called .NET MAUI Blazor Hybrid App, which basically allows us to have a MAUI project and a Blazor project. We can share or embed the Blazor project's output so that it can be run in the MAUI project. However, if we wanted to have some component reused to share components between the two projects, we basically had to create this project manually, add references, etc. So with this new project called .NET MAUI Blazor Hybrid and Web App, what is done is to separate those projects to have MAUI information in one project and Blazor information in another. And finally, a last project that will be the shared project where the different components will be shared. We click on the template and have to choose a name. Finally, here we select the .NET 9 framework, which is the only one allowed because this template belongs to this version of .NET. And you have to select the render mode for the Blazor project. So I won't do this because I already have a project created with these characteristics. I will open it quickly. Okay, here we have the project, and you can see the structure of the initial project. Basically, you have a MAUI project with all the features of a MAUI project. For example, the platforms folder where you have Android, iOS, Mac Catalyst, Tizen, Windows, etc. You have the Blazor project, which is the one that ends in .web. Here you have the Blazor components specifically that you want to use. You also have a shared project, which is the one that ends in .shared, where you will basically have the components that you want to use both in the web project and in the MAUI project. Here, as part of the shared project, you have a folder called Services. We know that an interface does not define platform-specific code, so we can take this service with these methods, implement it in the MAUI project, and here notice that the implementation to obtain this information uses a class called DeviceInfo, which belongs to the Microsoft.MAUI namespace to get the form factor on which we are running the application. Here, some string formatting is done to obtain both the name of the platform and the platform version. And in the case of the platform, environment.os version.toString is returned. So we see how we take advantage of the characteristics of each platform to perform different tasks. Now, something we can do is reuse code, as I mentioned, or components as part of the project. So to demonstrate this feature, what I will do is open the shared project, and in this folder called Pages, I will add a new Razor component. We will call this Razor component, for example, Flux Generator. And basically, this component has the following source code that I will copy and paste to speed things up a bit. Okay, I then have this source code. And I will change the API key of the service. Basically, what I am doing is connecting to a service called together.ai, which gives you a certain amount of tokens to generate images for free using their API. You registered, get the API, and you can use it without any problems or restrictions within the service's usage parameters. So what I'm going to do is indicate, once I have added this component, that I want to add it to the menu that is defined once again in the shared project. I open the Pages folder, actually I open Layout, go to Nav menu, and create a new section for this new element. Defined this way, I basically indicate that I want to navigate or show the user an item flux so the user can navigate to this element. Once I have done this, I will indicate that I want to place the Blazor project as the initial project and start it to see what happens. Okay, here we have the application. Let's go to the new element called Flux Generator. And there we have this nice component that will basically allow us to generate images. For example, a library in the middle of the desert. Let's generate the image. Okay, fantastic. We have this nice image. Here we have some information about the image. We could complete this component by adding functionalities like, for example, the ability to share the image, read more information about the image, etc. So this is a demonstration of how this component we have added works on the web. What would happen if we set the Maui project as the initial project? Well, the first thing I'm going to do is indicate that I want to run the application on a Windows machine, which is the device I am currently using. Notice that the behavior of this application is the same as we have in a Blazor project, but we are running the project inside a Windows application. I'm going to go to Flux Generator. We have the same visual part as before. Let's write, for example, a cat walking on the moon. We generate the image. Okay, we have this image. Let's regenerate it because it didn't look good. Notice that we have the image now, but using the application from Windows. Let's do one last test. Let's indicate that we want to use the Android emulator. Let's start the emulator. Let's wait a few seconds. After a few minutes, we see the application in an Android emulator. The incredible thing here is that we can go once again to the Flux Generator page and have the same behavior. We have this component that looks good, created from what we did for Blazor. Let's test it, for example, both writing code. Let's generate the image. Here we have the generated image. We basically have the same output from these different components. With this, we have reviewed the new features introduced with .NET version 9 in Blazor. I hope this video is useful for you and gives you a better overview of what you can do in this new version of Blazor. If you liked the content, remember to subscribe to the YouTube channel, like the video, and share it with your friends so they know about the new features of Blazor. See you in the next video.